So now we come back here, and in here we need basically a character array. And what we would do in this code, that basically we would use mkfifo function to create a FIFO special file, which we would name something, and then writes and reads from the same file before closing it. Okay. That file would not basically be created on our desktop or in our present directory. That would be a temporary file which would be created, and then after the program executes, that file basically goes away. It is, you can say that it is stored in the partial memory, not in the permanent memory. So that file would go away as we shut down the program or we shut down the computer. Okay. So now what we are gonna do, that we are going to name that file. Okay, so let's call that file Linux temporary file. Okay, .fifo, Linux temporary or Linux temp .fifo. All right, so now you put a semicolon here, and in here you basically write here the character for the output. And let's say we give it a value as 40, and in here we would put an equal sign, and after that we'll write here, let's say this is FIFO and we are writing, or this is FIFO and this is Linux. Okay, so let me just increase here 100 so that it doesn't give any space error. Okay, so now what we're going to do, that we're going to create two integer variables. One is going to be, let's call it RF, let's call the other one WF. Okay, so we'll put a semicolon here, and now we basically write here an if condition in which we would use the mkfifo. If that doesn't return 0, it means that it is returning -1, which is an error. And if it returns 0, it means that there is no error and we can move on with the process. So now I would write here mkfifo, we would call it, and inside of that would pass basically two arguments. One is the file and the other one is the mode. Okay, so let's keep it in the mode of s_irwxu. Okay, and then we put a not equal sign, and then we keep it to 0, and after that we create a body for the if block, and inside of the if block we write here the error message p error, and in here we write mkfifo. Let me just write double quotes first, then I write here mkfifo error. Okay, then I put a semicolon here, and after that I would have an else block here. So inside this else block we need to write a couple of other statements as well. Okay, so we'd write here if and then we write here rf equals open, and we say here fn o underscore read only. All right, and then we basically write here after read only we use the o underscore non-block flag that we have talked about. Okay, so we would write here the pipe sign, and then we write here o underscore non-block. Okay, and I have explained to you this flag earlier. All right, so let me put a bracket here as well, and then after that what I'm gonna do here, I'm gonna write here less than 0. Okay, if that is less than 0, then what it is supposed to do, that it is supposed to give us an error message. Okay, so we'd write that error message here, p error, and then after that inside of it I can write open error. Okay, open, or I can write this open error while writing, okay, or while on the writing end. Alright, so now I put a semicolon here, and now I would have an else block for that, and inside the else block I would have another if statement, okay. So if it doesn't give us a right error, then in that case we need to put another check, basically, you can say, okay. And that check would be if, then we'd write here right, and we'd pass few arguments, wf, and after that we'd write here out, comma, strlen, and inside of that we'd write out. And this strlen, stringlet, is the function that we have basically used because of this string.h header file, okay. So that is a built-in function in this string.h header file. So after that, what you are required to do is that you basically add 1 here, okay, +1, and then you are basically going to write here double equals -1. So if it is -1, then we are also, or you can put here less than 0 as well, doesn't make any difference. So we'd write here another error message, actually. So you'd write here p error, and you can see that how beautifully the code I have indented, okay. So make sure that you indent the code really beautifully, because it is more readable and it is more clear, okay. So now inside of that we'd write here right error. So if you do not indent your code for some reason, then it is going to work fine, okay. It will not give you an error like it does in Python. In C you don't need to indent, but if you are some person who like really cleanliness, then you can indent your code, okay. So this is a right error, so we put a semicolon here, and obviously we need to have another else if block, which would basically be for the read function. So we would write here else if, and then we put a condition inside the if. The condition would be the read, basically, okay. So read, let me just space here, read, and then we would have this function, and then we would pass the arguments. Number 1 argument is rf, and then we'd write here in, alright, for input, and then we would write here size of function, okay. So we would use this function, and we'd write here in as well, okay. So after that we are also gonna check it if that is equal to -1 or that is less than 0. No, it depends upon you that which condition you write, and we are also gonna throw error here, okay. So otherwise, if there is no error, then we can say everything is fine and there is no need to execute these error statements, okay. So we'd write inside of that, we'd write read error, okay, and then we come here, we put a semicolon, and there is the last else block that we need to write, because of which it would basically read from the created file, and obviously in the file we have this is FIFO and this is Linux, okay. This is what we have written inside of the file, okay. So we'd write here else, and obviously we would have 2 statements here, so we put curly braces for this else block specifically, okay. So now inside of this else block we are going to write 2 lines basically. So we'd write here printf. So inside here we would write reading, and then inside the single quote we write %s from FIFO, okay, and then we write here /n, and then we put a comma, and then we write here in, and then we write here the semicolon, okay. So after that we have to close the write function, okay. So would close it inside this else block. So basically inside of this if function we have this wf, so we need to close it, so we'd write here close, and we would write here wf, okay, and we would close the read function basically here, okay, so we'd close it right here, close, and then we write here rf. Alright, and then finally we basically unlink let me just go down here and make space here. So now finally what we would do, that we would close we would unlink this fn, okay. And one thing that I have forgot is here, so I have forgot to basically write here in, okay. We have the out file, so we also have to have the in file as well. Okay, so now we would go back to our terminal and we'd try to run our program, okay. So we would go something like this, and you can see that there is no error. So after that we basically /test, we run our binary file as well, and you can see that it is successfully reading from FIFO, okay. So this is FIFO and this is Linux. You can see right here that was the value that we stored, and now it is reading it perfectly. So now let's move on to the next topic. Okay, so the next topic is message queues. So a message queue is a linked list of messages stored within the kernel and identified by a message queue identifier. So a new queue is basically created by the message get, and obviously if the queue is already there, then you can open it by using message get as well, okay. So there are a few functions, the built-in functions that we're going to use in our code examples. So the first one is message get, okay. So the new messages are added to the end of the queue by message send, okay. So this is the another message send which basically add the messages in the queue, and we are also gonna discuss it inside our code, okay. So every message has a positive long integer type field, a non-negative length, and the actual data bytes, okay. All of them are specified to message send, okay. So you know, all of them you specify it and then you use every message has a positive long integer type field, a non-negative length, and the actual data bytes, which all of them which are mentioned and which are actually given when you're basically using message send, okay. So messages are fetched from a queue by message receive, okay. That is the one function that would also be using in our examples, okay. So this is message receive, and we don't have to fetch the messages in a FIFO order. Instead, we can fetch messages based on their type field. All processes can exchange information through access to a common system message queue. The sending process places a message onto a queue which can be read by another process, okay. Each message is given an identification or type so that process can select the appropriate message. Process must share a common key in order to gain access to the queue in the first place, okay. So in order to generate the key, we'd see that what we have to do when we'll be doing examples, okay. So the other two methods that we are going to use in the example, one of them is ftalk, okay, and the other one is message control, okay, CTL. So let me explain to you what each method does and what it is for. So if we talk about ftalk, okay, so basically it is used to generate a unique key that we were talking about, okay. And if we talk about message control, it performs various operations on a queue. Generally it is used to destroy the message queue or to delete the message queue, okay. If we talk about message send, data is placed onto a message queue by calling message send, okay. So basically you place the message on the queue in the first place using this. If we